Okay, so week 11 we're talking about polynomials, and the simplest of the polynomials we talk about are parabolas. So we've definitely seen parabolas, and what we're doing is just kind of an overview of all the different techniques we have to understand them and to graph them and analyze them. So to start out with, if we had this, y equals x squared minus 4x minus 5, what do we actually know about it? Well, we know it's a parabola because of the x squared term. We know it's a parabola that points upward because it's a y equals positive x squared. And we might just eyeball it and say if x is equal to 0, then y equals negative 5. And so we know that the y-intercept equals negative 5. But just by looking at it, that's what we know. So it's a quadratic, it looks factorable, it's a parabola pointing upwards, and the y-intercept would be negative 5. So the first thing you can do, if it's factorable, you should definitely factor. So we can factor to find intercepts. So here's our equation. We know the y-intercept is negative 5. If we were to substitute in x equals 0, we can factor to get this, which tells us that one of the x-intercepts would be negative 1, and one of the x-intercepts would be 5. So the basic graph would look something like this, where this is negative 1, and this is 5, but there are other things about the parabola we don't know. For example, how wide it is. So that parabola has the same x-intercepts, and this parabola has the same x-intercepts, but we don't know which one it is. So next up, we could also complete the square. And so complete the square, take half and square it, is sort of the mantra that I like to use. So here we go for completing the square. We want the x stuff all by itself, so we're going to add 5 to both sides, giving us this. And what we're taking half of is the b. This is like a equals 1, b equals negative 4, c equals negative 5. So we're taking half of the b term and squaring it to get 4. That's the number that we can add to both sides so that this is factorable. So when we add 4 to both sides, we get this. So this is always factorable. Notice how the half is the thing inside parentheses with the x. And to rearrange this so that it's in standard form or vertex form, we would subtract 9 from both sides, giving us this. So this is a parabola that's been shifted to the right by 2 and down by 9. So again, standard or vertex form. And then the last thing we could do is we could use x equals negative b over 2a to find the x-coordinate of the vertex. So if you don't remember that from Algebra 2, this is a good time to learn that. X equals negative b over 2a, and that's where, again, in standard form, the equation of the parabola, so in this case a would equal 1, b would equal negative 4, and c would equal negative 5. So substituting in x equals negative b over 2a would give us that x equals 2, so this is the x-coordinate of the vertex, and we would substitute into the original equation. So let's write that so you have it in your notes. Substitute into original equation, and this is to find the y-coordinate. So we get that y equals negative 9. So that would be our vertex of the parabola. So using all that information, we could actually come up with a pretty accurate graph. So we know that our x-intercepts are negative 1 and 5. We know our y-intercept is negative 5. And we know that our vertex equals to negative 9. So notice how the vertex corresponds to when we were saying the parabola is shifted right by 2 and down by 9. Those will be the coordinates of the vertex. Okay, so that's all fine and dandy. I think that you probably want some more practice with completing the square. So for these two questions, we're just solving to complete the square. So we have this equation, and we're solving. The x stuff is already all by itself, so we're going to take half and square it, and that's a number that we can add to both sides of the equation. So right here, we've taken half of 6, which is 3, squared it, and got 9. We add that to both sides of the equation so that this side is factorable. From there, you can then take the square root of both sides, and don't forget that when you take the square root of both sides, there's a plus or minus, so we actually end up with two answers. So square root of 10 plus or minus root 10, so we end up with negative 3 plus root 10 and negative 3 minus root 10. Completing this square gets more tricky when there's a coefficient in front of x squared. So here I subtract 3 from both sides first. The x stuff is all by itself. And you need a positive 1x squared in order for the take half and square it to work. So out of these, I have factored out a 2. So we have this positive 1x squared. Half of 10 is 5. We square that. So I'm adding 25 in here. This is obviously now factorable to x plus 5 squared. But because of the 2 being distributed to the 25, I'm adding 50 to the right-hand side in order to keep it balanced. This yes is here because this is not a mistake. So once we get down here, we can divide by 2, take the square root of both sides, and then subtract 5. So we end up with two answers. X is negative 5 plus root 47 over 2, and x equals negative 5 minus root 47 over 2. Let's take a look at the next page. Alright. Oh yeah, okay. So let us try this. We have an equation. I think that's a minus right there. That's pretty messy, but we're going to complete the square to put it in vertex form. We're going to list the coordinates of the vertex, and we're going to graph by hand accurately. So I think this was a student who started out doing this, and then I took over. So here's our equation. Looks like a parabola. It's going to open downward. So I am adding 5 to both sides to get the x stuff all by itself. We're going to take, so we need a positive 1x squared, so I've factored out a negative, switching this to positive x squared and this to minus 6x. So half of that is minus 3. Square it, we get 9. And because this is minus 9, we are subtracting 9 over here to keep both sides balanced. So y minus 4 equals, and the negative stays outside. This is factorable to x minus 3 times x minus 3. And then to put it in what we call vertex or standard form, the y needs to be all by itself, and the x needs to be in parentheses squared with a number, if that's the case. So adding 4 to both sides gives us this. So this is a parabola. It points downward. It's been shifted to the right by 3 and up by 4. And so we can say that the coordinates of the vertex are 3, 4, and the parabola opens downward. And I think that these intercepts, yeah, so here is our original equation, and if we factor out a negative and then factor it, we get that x equals 5 is a place where I should have a 0 over here. So we set y equal to 0 to get the x-intercepts. So we get x is 5 and x is 1 for our x-intercepts. So here's a nice accurate graph showing that, where we have the vertex, we have the x-intercepts, and we could also have the y-intercept. So here's x-intercept and x-intercept. And if we look at the original equation, the y-intercept would be negative 5, so down here, 1, 2, 3, 4. That's getting pretty messy. But to be as accurate as possible, we should also have the y-intercept there. So our y-intercept is negative 5. Okay. And then here, so this looks similar, only we now have this coefficient the 5 in front of the x squared. So to complete the square, I'm moving the 49 over. I'm factoring out a 5 so that I can take half of the b term, square it to get 9, and this trinomial becomes factorable to this. And what is this right here? Oh, okay, minus 49 plus 45 give us y minus 4. So we're going to add 4 to both sides. This is a parabola. It's going to be vertically stretched, so it will be thin, shifted to the right by 3 and up by 4. So we have our vertex is at 3, 4. It's a real thin parabola, and what we're seeing is that it's basically not factorable. So if you were to try to factor, you'd end up with imaginary numbers. So because this is the vertex and it points upward, it doesn't cross the x-axis. The y-intercept, however, would be at, so if we put in x equals 0, we get 49 for y, and so way up there, way up at 49 is where our parabola would actually cross. So even though there's not much detail, this is the best we can do, and we could say that our vertex, we could label it as 3, 4. Okay, so that complete the square stuff, that's definitely here to stay. I think that's all we have. Just blank. Okay, thanks for listening.